Good morning, Algebra 2s, or whatever time of day you happen to be watching this. Today we're going to go over page 7 on your Regents exam. That's questions 17 through 20. So we're going to, and look at, you can do all of them. That's exciting. Okay. So taking a look at number 17. Technically, this was Algebra 1, okay? A little harder. Consider the following patterns. Here you go. Which pattern is geometric? So what you have to know is that geometric is a pattern that you get by multiplying the same amount every single time. So I'm going to look at the two that I think are easiest. P.S. I hate these questions. I hate these questions. I'm going to look at number 2. So to get from 1 to 4 by multiplication, you have to times 4. Yeah, that's easy. So if this is geometric, it's going to continue multiplying by 4. Well, when I do 4 times 4, I do not get 9. So I know number 2 is not geometric. The next one I'm going to look at is option 3. To get from 6 to 18 by multiplication, you have to multiply by 3. 6 times 3 is 18. So if that is true, 18 times 3 should be 30. It's not 30. So I know number 3 is not geometric. So then it leaves me with these choice 1 and choice 4. These are disgusting, right? They're not so pretty. So this comes down to that trick that I've taught you several times where you take two numbers in the pattern that are right next to each other and you divide them. You take the one further down divided by the one in front, okay? So we're going to go calculator. So in option 1, we're going to do negative 12 divided by 16. There's your common ratio. Okay, that's the number you have to multiply by to get from one to the next. So if I take negative 12 and I multiply by negative 3/4, it should come up to be 9. Negative 12 times, copy paste. Hey, it came out to be 9. Look at 9. Now, if I take 9 and I multiply by negative 3/4, it should come out to be negative 6.75. So if I take 9 times negative 3/4, and it's a decimal, so I'm going to hit. Look at, there it is, negative 6.75. So this is geometric. I multiplied the same number every single time. Just to prove it, if I divide 2/3 by 1/2, that is not what I meant to do. There we go. 2/3 divided by 1/2. The common ratio is 4/3. Okay, so if I do 2/3 times that number, okay, if I do 2/3 times that number, it should give me 3/4. Let's see. Nope. And that's why number 4 is not geometric. Okay, number 18, consider the system below x's, y's, and z's. Which value is not in the solution? Now, guys, your calculator will do this for you. It's called LinSolve. And honestly, that's the fastest way to do it. So I'm just going to do LinSolve. So it's menu, 3. Oh. For me, it's 7. For you, it's not. Okay. Solve system of equations. Boom. There are 3 equations. Whoa. X, Y, and Z are the variables. Comes out to be this. Remember the top equation? X plus Y plus Z. Where is it? Equals 9. Second equation, X minus Y minus Z equals -1. And the bottom equation, X minus Y plus Z equals 21. So here they are. X is 4. Now yours will not say this. Yours will just have 4, -6, and 11. Okay? So those are my 3 answers. So it says which value is not in the solution. Well, X was 4. Well, that is in the solution. Y was -6. So that is in the solution. And Z is 11. So that is in the solution. So -8 is not in the solution. okay? We can do this algebraically as well. All right, here we go. Which statement regarding polynomials and their zeros is true? All right, so basically I got to go through all of these and see which ones are not true. So if I take a look at this, I know that I can factor that one more time. That's difference of squares. So what that would look like is x and x plus 1 minus 1, right? 1 times 1. And then x plus a is a linear factor already. That basically makes it so you cannot graph this in a calculator, okay, guys? So if I want to find their zeros, I would solve it. It's going to have a 0 at -1, at +1, and negative a. All right, so let's see what it says. It has zeros of 1 and negative a. They missed -1, so that's not true. I'm looking for which one is true. All right, take a look at this one. Oh, good Lord. That's gross. Where are we at? There we go. So notice 1, 2, 3, 4 terms. 4 terms, I'm going to look at grouping. So when I group these two together, it has a GCF of x squared. Okay, what's left over? X minus a. Boom. Okay, then I'm going to group together these two. It has a GCF of 16, positive 16, in fact. And what's left over? X minus a, which is good. So now that you look at this grouping, you say, oh my gosh, what's the GCF? Well, they both have x minus a. What is wrong with me today? What's left over when you take out that GCF? X squared and 16. All right, this is going to have a root at positive a. This is not difference of squares, but it's pretty darn close. We're going to treat it almost the same way, x and x. 16 is 4 times 4, but the difference is, because of this plus sign, we're going to throw an imaginary. One is plus, one is minus. So this one's going to have roots at negative 4i, and this one is going to be at positive 4i. So let's see what they said. Oh, good Lord, no. Nope, you're not right. Okay, number 3, same idea. This one is already factored, okay? This, again, is going to be imaginary. Oh, Lord, please. Oh, well, I know that's not going to be right because this should be 5i and negative 5i. So I know that one's not right. So, geez, this hopefully is the right answer, okay? Again, 4 terms, so we're going to go grouping. GCF of this group is x squared, leaves me with x minus a. GCF of this group is negative, because of that, negative 9, x minus a. Remember, when we take a negative, it changes the sign. So here are the factors. We've got x minus a as a GCF, and x squared minus 9, which is going to hit at a, and then that's difference of squares, plus 3, minus 3. So it's going to hit at negative 3 and positive 3. There it is. Woo! Oh, yep, say, yay, there it is. And last but not least, number 20, if you use NSolve, well, here's a little hint for you. If the solution of this quadratic equation is expressed in simplest a plus bi form. So they're basically telling you guys this is going to be an imaginary number. Well, look at these 4 answers. School bus just went by. This is not imaginary. And this is not imaginary. You're down to a 50-50 shot of guessing this sucker right. So what we're going to do in order to solve in simplest radical form, we have to use the quadratic formula. You cannot do that until this sucker is in standard form. So we got 5x squared, and we're going to do the distributive property right here. Boom, boom. 2 times 2 gives me 4x and negative 2. All right, so we're going to put it in standard form. This is positive. I want that to stay. We're going to move this over, and we're going to move this over. Here we go. This is A, this is B, that's C. X equals negative B plus or minus the square root B squared minus 4AC all over 2A. All right, here we go. I'm going to type that in. 16 minus 4 times 5 times 2. Negative 24. There's your imaginary, guys. All right. So let's take a peek. Let's be smart. This one still has a radical. This one does not have a radical. Is that a perfect square? No, it is not, which means there will be a radical in my answer. Right? Right? Let's reduce it. What the heck? 4 times 6. Right? 4 times 6. So we've got this 4 out in front. Let's go. Square root of 4 is 2. We're going to put an I in there. All over 10. Well, what on earth is happening? What did I do wrong? Did I do something wrong? Let's finish this up. 4/10 plus or minus 2I over 10 radical 6. Let's divide. Divide by 2. 2/5. Plus or minus, divide both by 2, which is I over 5 radical 6. What the heck is X equals negative B? What am I doing? This is not 2/5. That's not right. All right, I'm gonna have to take a break. I'll come right back. I'll fix it. I don't know what I did wrong.